Would you like to learn, understand, enjoy, and apply the beauty of physics for the Form 4, Form 1, Form 2, Form 3? That might be a question that you've been asking yourself for a long time. I don't know about what answers did you meet with when you've been looking for the solution or for the answer of that question. But possibly today it might be an historical day to you that you found the right answer that you've been seeking for several months, for several years, because you've been looking the comfortable and the conducive environment for you to learn the beauty of physics, the beauty of chemistry, and the beauty of basic mathematics. So you're warmly welcome. How are you, everybody who is watching these programs, whether you're a national, international viewer? You're warmly welcome. I really appreciate and I would like to welcome all the pre-Form 4 students in Tanzania, all the pre-Form 4 students in Africa, even in other parts of the world. I would like to welcome all the parents who are taking care of the Form 4, pre-Form 4, Form 4 students, QT students, reciters. You're warmly welcome into this comfortable moments when the teacher Olenjolai is going to meet you or is going to take you from the present state or from the present state of knowledge into the next state of knowledge, and then you'll find that you understand the concept that you have to cover as the students, and finally you enjoy our content. So my name is Olenjolai Moko TAYAI Losingo. Simply just call me Olenjolai. I thank God by His own grace, He has given me a gift. He has built in me a gift of teaching. So teaching is Olenjolai, Olenjolai is teaching. So it's a one of my interested work. It's a one of my excellent work for the rest of my life. I love so much teaching, and teaching loves me also, because we are friends and our only days that is going to separate us together. I'm also electrical engineer. I'm also a computer scientist. I'm a leader. I have other gifts that God has built into me. But today, I'll be standing in the gift of what? Teaching. So I'm a national and the international teacher of physics from 4. So I'll be teaching you by using a wide range and even a wide aspect of of understanding. So a broad aspect, but I'll be following and I'm using the syllabus. Currently, I'm teaching you physics by using the syllabus of United Republic of Tanzania. And remember that we Tanzanians, we don't learn new physics compared to the physics that being learned in different countries of the world. No. Physics, it's a cross-cutting subject. So for example, today I'm going to teach you about wave. The wave we are learning in Tanzania, it's the same wave that also middle school students are learning in British, are learning in Europe, are learning in France, are learning in United States of America. So that's why that if you're an international viewer, be comfortable. Don't be discouraged about maybe my nationality or whatever. That's not the case, because even myself, I used to take advantage from other educational systems in the world. Example, I'm a very good student, I'm very good online students of Massachusetts Institute of Technology, in brief we call it MIT. So I'm a Tanzanian and I'm doing this program for the Tanzanians. I would like to welcome all the national viewers, into all the international viewers into our beautiful country. We have so many national parks that you can take. It means that you can make your tourism. So we love so much tourism. We receive a large number of tourists monthly and even also in a year. So you're warmly welcome and feel comfortable to be in Tanzania. And whenever you come, expect you to meet with the presence of God for the rest of your life, which will make you a radical change in your spiritual and physical life. So I would like to take this opportunity to welcome our national and international viewers into one of our online schools that called Tanzania Online Ordinary Secondary School in square bracket Olenjolai. Simultaneously, I would like to welcome you into one of our official YouTube channel that called Tanzania Online O-Level Set School in square bracket Olenjolai. At the name proposed, we are going to create the contents for ordinary secondary students only. And these contents can help VETA students, can help diploma students, but those are subsidiary. Our main focus into also, that's the abbreviation of Tanzania Online Ordinary Secondary School in square bracket Olenjolai, is training and teaching what in ordinary secondary students. So then right now, possibly this is your first time to meet me, or maybe you didn't concentrate on the introductions of the previous video. You have so many questions in your mind. Olenjolai, are you solving my problem? Yeah, I'm solving your problems. Olenjolai, can you help me to master physics? Yes, I can help you. Olenjolai, can you help me to solve physics to solve different questions in physics? Yes, I am here to help you. Olenjolai, can you help me to restore my forsaken love of physics? Yes, I can help you. Olenjolai, are you solving my real life problems? Yeah, I'm solving your real life problems. Olenjolai, will you support me to meet my visions that need the knowledge of science and mathematics? Yes, here I am. But another question that you have in your mind, what the visions of the Tohoso? Well, in Tohoso we have a big picture, and this big picture is a declaration. So we used to declare it whenever we go, and we believe on this big picture because we received it from God. What is our vision, or what the visions of the Tohoso? The vision of the Tohoso is to teach and train ordinary secondary students on how they can extract knowledge, understanding from the classroom instructions in education, whether they learned formally or informal, and combine with the knowledge, understanding, and wisdom that you are going to extract in in the Word of God, written in the Word of God, written in the Holy Bible, in order to solve real life problems. So when I say about real life problems, I don't mean about the classrooms or the examinations problems. I mean about the real physical problems, the society's problems of Tanzania. It means the real life problems experienced in your country, experienced in your city, experienced in your village, experienced in your school compounds. So experienced in different, even the neighbor villages or in neighbor streets or in the different wards. So that's what I call real life, or that's what we call real life problems. They are not blackboard problems or classroom problems or examination problems. However, that will teach you about that, but that's not our main objective. Our main objective is to teach you to solve real life problems, to use the knowledge that we are teaching you, and we'll be training you for many years in order to solve real life problems. That is our main objective. But to have some specific objective, we'll prepare you for your continuing assessment, we'll prepare you for your next exams. We know that you'll have certificate secondary education examination for the Form 4, so we'll prepare you. So you should not be disappointed, because we want you firstly to have peace of mind in order to help you to have peace of mind, so we can inject new information, so we can take you beyond the classroom instruction. We have to make sure that we cover everything that we're supposed to cover, or make you to be astonished with thinking outside the box. And then from there, we draw you to think outside the box while you have all the contents and you have peace of mind that everything is well solved and everything is well taught. So now I can think outside the box. Wonderful, that's the technique. So we'll be using different teaching aids to teach you. We'll be using different teaching approach to teach you. We'll be using different teaching methodology to teach you, in order to make sure if you're a slow learner, don't be disappointed. Olenjolai will help you. If you're a faster learner, don't be disappointed that maybe most of your teachers, they fail to teach you, or they fail to define you that you're a faster learner. I understand that they are faster learners. Don't be discouraged. I will accompany you. I will teach you in order to be satisfied. If you're intermediate learner, also don't be discouraged. That's the level that God has given you. Be thankful to God and use it effectively to cover and go the distance where God has planned you to go. Right? So make sure that. So this is the national program. It's not a certain school program. This is the national program, so that my wish, it means my vision, I would like to see ordinary secondary students are blessed and being taught through this program lifetimes from now onwards, for the present and future generations, including even our children's of the children's. They have to take advantage of these contents. And I'm solving real life problems, and I did a research. So what I'm solving is a critical and complex problems that most students, they used to quit mathematics, they used to quit physics, they used to quit chemistry. Why? So, ladies and gentlemen, I would like to spend a few minutes to just present to you a few steps that you have to follow in order to register into TAYAI. To also remember, Tanzania Online Ordinary Secondary School is going to bracket for July. So the first step, we ask you, if you don't have email, create or open a new email. The second step, we ask you to sign in YouTube by using the email that you have created, or your old email. You'll be asked to have a username and password. Then the second step, we ask you to search TAYAI in YouTube. So search it also. Don't write also because it's not there. What is there in YouTube, save us. you'll find this our official YouTube channel name called Tanzania Online O-Level Seki School in square bracket Olenjolai. Just write that in the YouTube search engine and then click the search buttons. You'll see, what will you see? You have to make sure that you see a round buttons with the Tanzania national flag. This is the Tanzania national flag. Beside it, at right hand side, you will see Tanzania Online O-Level Seki School in square bracket Olenjolai. Right? And then you see the number of videos. We thank God by His own grace right now. We have published more than 100 videos, but we have a vision of publishing more than 600 videos. So join us every day. Make sure that you visit this channel every day because we are adding at least one video for our students every day. So then we see the number of subscribers. We thank God for His own grace. Right now we have more than 100 subscribers. It means these are the active students who will receive the notifications whenever we add any new session or any new periods or any new lecture. Again, we ask you to click these round buttons in order to get, because this is to also posters. Whenever you go in the school poster, you see that the Ministry of Education and Vocational Training, the President's Office, whatever, Nazimoja, or maybe Kilangalanga Secondary School. So our school motto you see there. So for us, you see the Tanzanian national flag, and that is the welcoming, that welcome to Tanzania, welcome to your beautiful country. So click these buttons once, and then you'll find that you're already in our online schools, in our Toso school. Then you'll see, what will you see? At the top, you'll see, it means that one of the contents that you'll see horizontal toolbar, written home, videos, playlist, community, if I will create a community right now that I didn't create, channel, and then channels. I have also some other 5 channels of training that you can see them below of this if you scroll down, and the word about, and then if you're using a computer, you may see the search option, right? So I will come later into this horizontal toolbar because it's very powerful, and also it can minimize much of your hassling on searching our content. Ladies and gentlemen, let me welcome you into the steps 5. So step 5, look the buttons which is written subscribe. It always has a red background before you apply the effect, and then it has a white text. So we ask you to click it once, just to click it in this way, just click it once, and then the text will change into the subscribing. Once you do that, you will see the icons of the bell, right? The icon of the bell. We ask you to, once this text changes, then you see the icon of the bell. Before you subscribe, the icon of the bell is not there. We ask you to click this icon of the bell once, and then choose options of choose options of off. So after you do that, then you have already registered yourself permanently into also. You don't need, you register once and it's free. No any registration fee. And our contents are providing free. No any charging fee, right? No any tuition fee. It doesn't mean that we cannot charge you, but we are not asking you to do that by the founder and the owner of these programs and the sponsor whose goals are online. Again, we like to just give you a brief, a simple way for you to access our content so to minimize your hassle. You have to come back into this, just check this horizontal toolbar. Click this with written playlist. Then you will see more than 10 playlists you have created for ordinary diploma secondary education. Once you see this, what the means of playlist? We are teaching, for example, in physics, we are teaching you all the topics of physics for the Form 4. So in each topic, we create a playlist. And in that playlist, we actually collect the related or all the sessions from session 1 to the last sessions of that particular topic. For example, now we have a playlist that's called the Wave. So search the playlist of Wave, you'll find the collections of all the videos that we have taught you about Wave. Today we are in session 5. It's a video on the Azoti mechanical wave. Okay, so this is session 5. So the previous sessions you can access them in our YouTube channel, Tanzania Online O-Level Seki School, square bracket Olenjolai. In the playlist of Wave, you'll find well organized rather than searching because you don't know how you name session 3 or session 4. Wonderful. So I believe that you take that advantage. Or you can go into the playlist written physics for the Form 4. This playlist contains the videos for all the chapters of 40, for all the, How many chapters do we have in Form 4, if you do remember? We have 8 chapters, if I'm not mistaken. Yeah, 7 chapters. 7 chapters. We have electromagnetism, radioactivity, semiotic emission, electronics, elementary astronomy, and geophysics. So you'll find the videos for all the chapters, all the 7 chapters of physics for the Form 4 here. Again, we know that you love our contents, and then so you'll be asking yourself how you can share this content to other students. So we ask you to click the icons written share, to share this video link to other students via the social media, example Facebook, WhatsApp, email, Instagram, Telegram, Twitter, TAYAI, and we welcome you into to also to love physics for the rest of your life. Then students, welcome into departments of physics. We have so many departments in this online school. Welcome into the subject of physics, and these contents we dedicate to the pre-Form 4 students, or Form 4 students, or QT students, or reciters, or teachers who are teaching physics in Form 4, or diploma students who are doing different programs that needs the knowledge of physics, and even better students who are doing NTA level 1, NTA level 2, NTA level 3, maybe in a particular field of technical. So we are chapter 1 called waves. This is session 5 called mechanical wave. Ladies and gentlemen, let us go into the business because this is a science class, right? So quick review. So I believe that you have enough information. Quick review of what? So the previous session, ladies and gentlemen, is called this session 4. And then in that previous sessions, it has been named as problem what? Or solving questions. So I think that solving questions might be named a little bit different from this name. Solving questions of 40 parameters of wave. So we mentioned parameters of 40 of waves. Parameters of waves, we told you that we have some parameters of wave. One of them is called the amplitude, right? Amplitude. And also we talked about crest and trough. Crest and trough, if you do remember. Okay. And then we talked about frequency, another parameter of wave is called the frequency. Then we talked about wavelengths, right? Wavelengths, which also have wave number. We taught you also another parameter that's called the wave velocity or velocity, right? So then the formula, the fundamental formula that we've been dealing with is what we say that the velocity of the wave is equal to frequency times wavelength. So velocity or speed of the wave is frequency times what times wavelength. So this is the formula that we've been working on. And then sometimes you might find that we have velocity 1, we have frequency 1, we have wavelength 1, then maybe we divide with velocity 2, we have frequency 2, we have wavelength 2, etc., etc. It will be solving different problems. So today, we'd like to teach about mechanical waves. But before we teach about mechanical waves, let me build the strong foundations. Where do we get mechanical wave? We've defined the term wave. So right now, let me take you into types of wave. So what are the types of waves in physics, right? The answer of these questions, we may answer it in 2 different ways. Depends in which level that I have asked that questions, because we have the fundamental, main types of physics, main types of wave, and also we have advanced main types, advanced types of waves. Types of waves. So we say that in fundamental or in basic physics, she called it fundamental. In fundamental physics, there are 2 main types of waves, namely due to it, and this is due to direction of energy, the directions of energy carried by the wave, and the orientations of what? And the orientation of particle motion. Orientation of particle motion. So in fundamental physics, there are two main types of waves due to the directions of energy and directions of energy and the orientation of of particle motion in a wave. So these two types. These are, the first one, we call it a mechanical wave. Say with me, mechanical wave. Mechanical wave. The good news, because 75% of Form 1 students did their primary education in Swahili language, we are the only one who we can teach them Swahili in two languages, English language and Swahili language. So if you have your young brother struggling for English, then you may tell him or her. So mechanical wave. And then we have what? Electromagnetic wave. Electromagnetic wave. So those are the two types in fundamental physics, even for you as O level. This is what you have to teach you. But we believe that later on you'll study advanced physics. So in advanced physics, if you want to say that, to learn about the types of waves, there are three main types of what? Three main types of waves. Due to it. Due to direction of energy carried by the wave, due to the directions of energy, and what? And the orientation of particle motion. The orientation of particle motion. Orientation of particle motion in the wave. So it means that if you be learning about advanced physics or advanced wave, then we can have three types of waves. But when we are teaching our students about fundamental physics or fundamental wave, we're introducing the concepts of wave for the first time. Then we have a responsibility to teach them only two types of wave. But it doesn't mean that those are the only two types of waves that we know in this context. So these three types of waves are, the first one. The first one is called the mechanical wave. Mechanical wave. The second one, even also in advanced physics, you have say with me, electromagnetic, not electromagnetism, electromagnetic wave. And then the third one is called the surface wave. Not surface, matter wave. Matter wave. The third type is called the matter. Say matter wave. You know the matter. Matter is anything which has what? Or matter is any substance which has both, which has what? Magnitude and what? Magnitude and the matter is any substance which has mass and it can occupy what? Space. So matter wave, and this one is what we call in the modern physics as what? Quantum physics. So quantum physics is all about what? Matter wave. We won't touch even the matter wave because it's beyond your syllabus. We'll be teaching you all the mechanical, and we'll be teaching you in detail about mechanical waves. That's why session 5 has been titled as mechanical wave. And we'll introduce to you about electromagnetic waves, and we'll never say anything about matter wave because you will cover this when you'll be in undergraduate or in undergraduate level or bachelor level at university level. That's the point that you can understand or be introduced in detail about quantum physics or matter wave. And if you take a course that relating with that. Ladies and gentlemen, you can pause the video and then list those 7 steps of register of yourself your personal registrations to also, and then you will take the advantage of them. Thank you for doing that. So pause the video and then list those 7 steps for you to apply them in order to register yourself permanently and in order also to access our contents in a very simple way. Okay. Thank you for your faithfulness and thank you for registering yourself. Welcome to the OSO. Welcome to the OSO. Welcome to Department of Physics. Welcome to the subject that we call the physics for the Form 4. Welcome to the first topic in physics Form 4 that we call T-Wave. Okay, so now let us get into detail about it. Let us get into details about these 2 fundamental types of wave. And let me start with number 2. And there's a reason to start with that because these sessions, the heart of these sessions is all about mechanical wave. So the first type of wave, which is the second in this, you can say even the first is electromagnetic wave and second is mechanical wave. It's not mandatory that mechanical wave should be the first, no. It's just the issue of numbering. So let me teach you about electromagnetic wave that we see it every day in our daily life, but we don't define it as electromagnetic wave. So the fundamental question 5.1 for this session, what is electromagnetic wave? What is electromagnetic wave? What is electromagnetic wave? That's a question that we have. So ladies and gentlemen, we say that electromagnetic wave I found 2 definitions of it. So electromagnetic wave, we say the type of wave, but simply say that the type of wave in which it results so the type of wave in which it results from what? So it results from what? So it results from traveling oscillation it results from traveling oscillations of an electromagnetic field of electric field, no, not electromagnetic, of electric field. I want to use the simple language. So in the type of wave the type of wave which result which results from what? Traveling oscillations of an electric field. Let me write in this simple language. And what? Magnetic So it's a result from electric field and the magnetic field. So electromagnetic waves, the type of wave which result from what? Traveling oscillations of electric field and the magnetic field. And magnetic field through either through vacuum. This, they can travel through the media, but the goodness of them is the magnetic waves only can travel through are the only waves which can travel through the vacuum. Simple definition, listen carefully, my dear student. What is the electromagnetic wave? Electromagnetic wave is a wave result from traveling oscillations. Say oscillations. Oscillations means disturbance. Traveling disturbance of what? So the disturbance here is acting on the electric field and magnetic field of the what? Of the wave. Through what? Through vacuum. So this means that electromagnetic waves do not require medium of transmission. So not require medium of transmission. No, it's not like mechanical wave. Mechanical wave need medium of transmission. So that's why that we say that these, they can travel even in the vacuum, while mechanical waves cannot travel in the vacuum. Okay? So that is the definitions of definitions of electromagnetic wave. But we have a second definition. Okay, we have a second definition. Or in physics, electromagnetic wave waves. So in physics, electromagnetic wave is a type of wave which consists in electromagnetic field, which consists of electromagnetic field propagating through space. Propagating through space. Carrying electromagnetic radiation or energy. Carrying what? Carrying electromagnetic radiation, electromagnetic radiant energy. Carrying. So electromagnetic waves in physics, you say electromagnetic wave is a type of wave which consists in electromagnetic field propagating through space. So propagating through space, it means traveling through space. Okay? Propagating through space, carrying what? So propagating through space while they are carrying what? Carrying electromagnetic radiant energy. carrying electromagnetic radiant, carrying electromagnetic radiant energy. So that's the second definition, or another way that of defining the term electromagnetic wave. Okay, so I think that because of the intensive contents, and I want to make sure all the Form 4 students, they have to understand the subject of physics. I would like to change the title, the name of this session 5 to be types of what? Types of waves. So types of what? Of wave instead of mechanical wave. Then the next session, session 6, I'll teach about types of what? Mechanical waves, right? So I'll teach about types of mechanical waves. So I'll teach about types of what? Types of mechanical waves. So in these sessions, I'm teaching types of what? Of waves. So the first type that I began is what? Electromagnetic waves. So say with me, electromagnetic waves. Say again, electromagnetic waves. Say with me, electromagnetic waves. Again, electromagnetic waves. Electromagnetic waves. So you have to remember this terminology of electromagnetic waves for the rest of your life. So after defining the first type of wave that's called electromagnetic waves as the types of the wave which resulted from traveling oscillation of an electric field and magnetic field through the vacuum. So vacuum means that no any mediums of transmission. Medium of transmissions of the wave, it might be air. When say that example of media, air is a good transmission. For example, you hear my voice here because the sound wave, it's an example of mechanical wave. So you need medium for transmission. If, for example, I remove all the air in this classroom, then whenever that I speak, you won't hear my voice. It's not a problem of audio parts or microphones or whatever, no. Then, so we say that electromagnetic waves do not require what? This is the very important point. Electromagnetic waves do not require medium of what? Of transmission. So they can travel in the medium, but also they can travel in the place where there is no medium. Or in other words, in physics, you define that electromagnetic waves is the type of wave which consists electromagnetic field propagating. When we say electromagnetic field, the word electromagnetic field, it's a combination of the two words. Electrically, up to here, electrically, then there's an or as a conjunction, magnetic. So electric field and magnetic fields, together we call them electric fields, electromagnetic fields. And these electromagnetic fields propagating through the space, carrying electromagnetic radiant energy. So it's carrying electromagnetic radiant energy. So these waves carry what energy from one place to another place. So ladies and gentlemen, we have again another question. This is question 5.2. Okay, mention 7 examples. This is the examination question. 7 examples of what? Of electromagnetic waves. Okay, 7 examples of electromagnetic waves. So electromagnetic waves also are known as light wave. Okay, light wave. So we say that solution, we say that you have to note before electromagnetic wave is also known as what? It's also known as light wave. Light wave. So because it's light wave, so let us start from what? The electromagnetic waves. The first example is called radio wave. And this radio wave, so remember the electromagnetic spectrum. Radio wave. So radio wave. So radio wave, these are the electromagnetic waves which have the longer wavelengths and shorter frequency. Longer wavelengths. Longer wavelengths and what? So these are the longer wavelengths, short frequency, less energy. So in say radio wave, for example, we used to have radio which are FM bands. So the radios that broadcasting in FM bands, they are using what? They are propagating radio waves. And also we used to have AM bands, right? AM bands. Also you have heard about what? About the VHF, very high frequency waves. You have heard about ultra high frequency. So all of these bands of waves are found in radio waves. We call it, this is also telecommunications, electromagnetic waves, or this is what radio waves is the one of the waves we use in mobile communication, is the ones of the waves that we use in broadcasting, radio broadcasting, TV broadcasting, satellite broadcasting. So it means that these radio waves are useful waves. So that's why that whenever we teach about wave, we are teaching you on how you can solve real life problems. The second example of electromagnetic waves is called the microwave. In short, microwave. So this is the shortest. Radio wave is RIW, that is short. So microwave, say microwave. So microwave, these are the waves, or this is the electromagnetic waves which have higher frequency to compared to what radio wave, but has what shorter wavelengths compared to what radio wave, and high energy compared to what radio wave, right? So I'll be mentioning them in the sequence of what decreasing wavelengths while increasing frequency and what and the wave energy, because these waves are carrying what energy. So microwave, we are using in telecommunication. We have microwave dishes. You see them in telecommunications towers, right? So that's microwave dishes. Then the third type is infrared. So infrared infrared wave. So infrared waves. This we call it IR wave. Infrared waves. So infrared wave, it's example of electromagnetic wave. This is against another wave which we use domestically. For example, we have remote AC remote. So we say that when you say infrared, it means all the remotes that you see, most of the remotes, AC, air conditioning remote, televisions remote, radio remote. So they are using infrared, because the infrared communication, we have a transmitter, the remote is act as transmitter, and the radio or the air conditioning machine or the television, the television's receiver, all of them, we call them, mean that they communicate wirelessly, but with the context of line of sight. If this is the radio receiver or television receiver or air conditioning receiver, and this is the remote, you cannot turn it when the remote is above at this point. Why? Because it's not the line of sight. Only you can turn if it means that the line, if you draw the line from this transmitter to the receiver, is a straight line. If just you go down, so you cannot turn it on. That's why that we have to make sure that you make the line of sight between the receiver and the transmitter. So that's, we are using what? Infrared, say infrared. So television remote uses what? Infrared communications to, so you see that how physics is beautiful. That's what I told you, that the main objective of to also is to teach you to solve real life problems, because in our homes we have so many remotes or televisions or radio remotes that are not working. So you can figure it out, because you can apply the concepts of physics, or maybe you find that there's ignorance and whatever, so you can figure it out, you can fix it. Then the first types of what, the first example of electromagnetic waves, we call it a visible wave. So visible wave, this is the wave that we can see by using our naked eyes, right? Our naked eyes, so visible wave. Also, this is the one of the visible wave. This is used in what? So this is the wave used in fiber communication. So in fiber communication, fiber, it's a guided communication medium which transmits light from one point to another point with a very high speed. But that light is visible, so that's why I say that is within the range of what? Of visible light. Then the fifth example is called the ultraviolet wave, or in short you got UV wave. So this is useful, for example, in chemical reactions or preparations of tetrachloromethane. So use the UV light, ultraviolet light. So this is also used in what? In producing the PCB boards in electronics. Then you have the 6 example of electromagnetic wave. So the 6 example of electromagnetic waves is what? It's what? It's gamma rays. So gamma rays. And then the 7th example of electromagnetic waves, we call it X-ray. X-ray. So remember, X-ray, it's an electromagnetic wave which has high frequency, shorter wavelengths, and high energy. It carries high energy. So you know where these X-rays are used? In hospitals. Used in hospitals just to diagnose what different parts of the body, for example, bone cracks and whatever, and so forth and so forth. Gamma rays, this also get the gamma particles. So gamma rays are a little bit different from what gamma particles that we used to study in what in radioactivity. That will be the set topic of what of physics form 4. If you have any question about electromagnetic waves, please don't hesitate to ask your question in the comment section, please. Please use the comment section to submit your homework. Use the comment section to interact with me, ask a question. Use the comment section to establish the online group discussions with other students from other schools. Use the comment section to give us feedback, whether you understand us or not. So give us, use the comment sections again, just to ask any question, and use comment section to ask any help, because in most of the software there's a help part. So ask your help in the comment section, please. And use the comment sections also to give us feedback. You're enjoying of your physical location. You're enjoying this content from where in Tanzania or where in the world, and from which schools and which class are you? Are you from 4 students? So tell us in the comment section, please. So that's those are the 7 examples of electromagnetic waves. So ladies and gentlemen, let me teach you about the second type of wave. And this second type of wave is called mechanical wave. Mechanical wave. Say mechanical wave. Mechanical wave. So what are the mechanical waves? Good news, I have formed 3 definitions of mechanical wave, because this is what we have to make sure we teach our Form 4 ordinary secondary students, and they have to understand, because most of the question will test their understanding on mechanical wave rather than magnetic waves. So here, ladies and gentlemen, we have question 5.3. What is mechanical? What is mechanical wave? And the question we have. What is mechanical wave? So the response is this: mechanical wave. So I have found 3 definitions. You may choose either of them. Mechanical wave is a type. So it's a type of what? It's a type of wave which propagate, which oscillating which oscillating in a matter and they transfer energy through a medium. And transfer energy through a medium. So mechanical wave is a type of wave which oscillating in a matter and transfer energy through a medium. That's mechanical wave. It's a type of wave which oscillating in a matter. Remember, what is matter? Matter is any substance which has mass and occupies space. And it transfer energy through what? Through media. That's the first definitions of what? Of mechanical wave. Or, in other words, we define mechanical wave. So say mechanical wave is a wave that is an oscillation that is oscillating in a matter and responsible for it, for transfer of energy through the medium. And the responsible, so mechanical wave is responsible responsible for transfer of wave energy through what? Through the medium. Through the medium. So mechanical wave is a wave that is oscillating in a matter, and responsible for what? For transfer. So responsible for transfer of wave energy, through what? The medium. So this is the wave that is oscillating in a matter. So oscillating where? In a matter. It can oscillate in a stone, it can oscillate in air, in gas, it can oscillate in liquid, that's how. But it's responsible for the transfer of wave energy through a medium. Or mechanical wave I'm giving you plenty of definitions in order to choose either of them, which might be simple for you, because I'm teaching thousands of students, so they might have different choices on definition. So mechanical wave is a wave which can only travel. Through matter is only wave that which can travel through a matter, and when it's doing so, this is traveling through the matter, lead what? This is our lead there. Lead the disturbance So this one means the disturbance of the medium. So simply this is the wave which can travel only in the medium. So all the three definitions mention what? Medium, medium, medium. All the three definitions mention what? Matter, and then here we mention matter, matter. So that is the keyword. Then we have what in doing so disturbance of what? Of medium. So simply it means from these three definitions you can draw one key point, but not before. Mechanical waves. Mechanical waves. Mechanical waves can only travel through what? Through a medium. So mechanical waves are the only waves which can travel, or are the waves that are the only wave which can travel in the what? In the medium. So mechanical waves cannot travel in vacuum. Mechanical waves can only travel in what? In the medium, either air or either gas or solid, so in any medium, right? Can only travel through a medium. So that's the first point you have to note. The second point is this. Mechanical waves can not travel in the vacuum, while electromagnetic wave can travel in the vacuum. And also remember, electromagnetic waves can travel in the medium. So electromagnetic waves can travel in both mediums and vacuum, while mechanical waves can travel only in the medium, but it cannot be transmitted through the vacuum. Okay, so that's the very important fact that you have to remember as a level of physics. So I'm about to end this session 5 because I was focusing on examples of waves. So we have examples of what? We mentioned 2 examples of what? Mechanical waves. I thank God by His own grace, I found some examples of mechanical waves. And there are 6. So these are namely as what? So the first example is what? Sound wave. Sound wave is a good example of mechanical wave. So now you hear my sound. So the sound you hear is a good example of mechanical wave. Then we have the second example. Second example of mechanical wave is what? Is water wave. It's water wave. Then we have the third example. We have also spring wave, produced by the spring. And we learn these spring waves in what? When we'll be teaching you the next session, that's session 6, about types of mechanical wave, longitudinal and transverse wave. So we have spring wave. Spring. Then the second example we have what? Spring. Okay. So you have what? You have spring wave. You have spring wave, and a good example of a spring wave, you have what? Helical string. And hence you have again the fifth example of mechanical wave, which we call it is a seismic wave. Seismic wave. And have the sixth example. Okay. So you have spring wave, ample helical spring. Because you have spring wave and string wave. But again, another example of mechanical waves. We say that because those are the strings. I'm trying to think about. Okay, these 5 examples are enough. We can mention the 6, 7 example, the 8 example, etc., etc. So these are enough. So we have sound wave. Sound wave, it's a wave that I'm applying, that I'm using without transfer the energy of understanding of types of wave into your mind. Water wave. Water waves, this is the waves that we may have, or we may have the experience whenever there's something is dropped in, then we find that it's makes what is, or we created the water waves. Then you have spring wave. Spring wave, for example, that you can have a certain spring, and then possible that it has been in such a way. So that's what we call the spring wave. You have string wave. String wave, you have just a string. For example, in the guitar, you have so many. We have 6 strings that you can plug them and then produce a mechanical wave. Then you have seismic wave. So these are the underground waves that always used to develop when there is an earthquake that taking place. Okay, so those are the examples. So you may fill the blank. 6, 7, 8. So those are the examples of of mechanical waves. So in this topic, you will be focused on mechanical waves rather than electromagnetic waves. We'll teach you electromagnetic waves when you get into the Form 6 class, because you have a very special topic that's called electromagnetic. Okay, ladies and gentlemen, we have now the homework. The homework. So homework of what? Homework 5. And this is it, will be example 6. So example 18, example 6. Example 6. So example 6, ladies and gentlemen, we say that this is the question, right? Briefly explain at least 3 differences between what? Mechanical wave and the electromagnetic wave. So briefly explain at least 3 differences between mechanical wave and electromagnetic wave. So these questions will test about your understanding on on the concept that I've taught you, mechanical wave, electromagnetic wave. So just briefly explain those 3 differences, because these are commonly questions in NECTA, in most of the past papers of NECTA Form 4. That's nectar. Okay? So, ladies and gentlemen, I would like to say that this is the end of watching. This is the end of session 5, Types of Wave. That's the title. I would like to welcome you in session 6 when I'll teach about types of mechanical waves, or I'll teach about longitudinal and the transverse wave. So get prepared to enjoy the beauty of those types of watching of waves and apply in solving or figuring out your own problems and our own naughty problems. So that is what we can say about wave. So please remember to ask a question in the comment section. Make sure to do the homework on your own and then just submit the comment section. Remember to subscribe below. Remember also to like our video, to share this video link to other students. And then remember also to pray for us. We are always praying for you. So we thank God for His own grace. We'd like also to invite you to offer your free incense giving of an amount. So that telephone number 0759745331 and to be paid effectively in order to make sure that we transform our students. So make sure that you subscribe, please. Ask a question in the comment section. Read the descriptions below of this video for you to get more information. Remember also to register yourself and visit our contents according to the playlist and keep enjoying the beauty of the beauty of watching of physics for ordinary secondary education for. So that's the end. This is Olenjolai. You are physics, your national and international teacher in physics. I want to say thank you for joining me. I invite you to join me in the next session, which should be session 6. Make sure that you don't miss it, because the space for you is already prepared in heaven. Okay, the space for you is already prepared in heaven. So you just have to accomplish the mission. So if that's the case, then ladies and gentlemen, I would like to say that this is the end, and I love you so much, and I will miss you until we meet in session 16. May God bless you abundantly and keep you for the rest of your life. So be blessed, keep praying for me, and keep praying for you. Amen. Okay, again, before excuse me for interrupting you once again. Still have a very important announcement. As I said, that you can offer a free incense giving through this telephone number 0759745331. Offer it to God, and then your free will or incense will be received in heaven, and you will receive the total blessing for your generosity. So the first, so we have also Tanzania Online Ordinary Library. So we have so many reference books that we like to equip our students. The first one is called the Physics Syllabus for Ordinary Secondary Education from 1 to Form 4. We recommend our every students to have this book in hand. Okay, so you can order this book. It's only price of 40 or 15 Tanzania shillings. We order this one with a price of only 15 Tanzania shillings. But again, we have we have a textbook. We have 2 textbooks, right? So the first textbook is called the Physics Form 1 and 2 Students book. I recommend this book because it's been written by using the current syllabus of Tanzania. So Physics Form 1 and 2 Students book, order it, because you are going to solve so many questions in this book, so you should have it in your hand, right? So again, we have also Physics Form 3 and Form 4 student books. These are 14,000. Okay, so Physics Form 1 and Form 2. So the price is 15,000. So this is 15,000 and this one is 15,000. You may order both of them, including the syllabus, then you get the discount in transporting to your place, and also you get greater blessing from our Father who is in heaven. Again, you need this called the Form 2 Physics Review, Problems and Solution from 2003 to 2019. This is ordinary level physics in Problems and Solution from 2003 to 2019. Okay, wonderful. So that's the point that you have to remember. So you may order this one. This is not 15. This is 15,000 Tanzania shillings. This is 13,000 Tanzania shillings. Tanzania shilling, right? So you may order this package and then we may send it anywhere across the entire country of Tanzania. So order this package and we put in the box and then we ship it to you wherever you are, in order to make sure that we accomplish our mission. So may God bless you and keep you abundantly. Let us keep praying for each other. I'm praying for you. I ask you also to pray for me so that we may accomplish or we may do and complete this great work for the rest of your life. So keep enjoying physics. This is Olenjolai from beautiful country Tanzania. Keep on.